In October 2017, a telescope in Hawaii caught something impossible, an unknown object hurtling out of our solar system at a mind-blowing speed. At first glance, researchers figured it was just another asteroid or a common comet. But as the orbital data came in, the reality was a shocker. It wasn't approaching the sun, it was already heading out. This thing was an interstellar traveler. For 4.5 billion years, our planets, asteroids, and comets have been orbiting within our solar system. But this was different. This was the first space object ever detected that came from interstellar space. Its most striking feature was that it resembled nothing seen before. For the first time in human history, we had detected an object coming from another star system. Scientists named it Oumuamua, which means the first messenger from afar in the Hawaiian language. So, was this mysterious object really just a piece of rock, or was it something else? Today, on Future Theory X, we examine that mysterious messenger, the first object in human history to come from another star system, to pass silently by, to challenge known laws of physics, to divide the scientific world, and then to vanish into deep darkness. The lines above were just the beginning of one of the most remarkable discoveries in human history. October 19, 2017, the Pan-STARRS telescope was conducting its routine observations. Astronomer Rob Warwick noticed something unusual while analyzing the data. The object on the screen was moving extremely fast, and its orbit was unusual. Normal asteroids orbit the Sun in an elliptical shape, but this object was in a hyperbolic orbit. This meant it had entered the system from outside and would never return. Its speed was exactly 315,000 kilometers per hour. Just think, traveling from New York to London at that speed would take less than 2 minutes. The object had approached the Sun and gained speed from its gravitational pull, but the real problem was that scientists had noticed it too late. Oumuamua had already passed the Sun, crossed Mars' orbit, and was rapidly moving away. There were only a few weeks left for examination. When the first data came in, the scientific community was once again astonished. Oumuamua's brightness changed dramatically every 7.3 hours. This indicated that it was rotating around its own axis. But the change in light reflection was extreme. When they crunched the numbers, they found a bizarre shape. Oumuamua was at least 10 times longer than it was wide. It was approximately 400 meters long, but only 40 meters wide. Like a cigar, a cigarette, or a spacecraft. Never before had a natural celestial object with such extreme proportions been seen in our solar system. Avi Loeb, an astrophysicist from Harvard University, posed a startling question. What if this is an artificial object? Intense discussions erupted online. Theories about aliens were proposed. However, Loeb was not joking. He had unexplained data in his hands. In January 2018, a team from the European Space Agency discovered something surprising. Oumuamua was moving faster than expected as it moved away from the Sun. Normally, this kind of extra acceleration is seen in comets. As they approach the Sun, ice vaporizes, and the escaping gas creates a rocket effect that pushes the object forward. However, Oumuamua showed no gas cloud, no tail, and no signs of vaporization. So, how was this object accelerating? Avi Loeb and his team published a paper. If Oumuamua had a very large and thin surface area, the radiation pressure from sunlight could have pushed it like a sail. But for this to be the case, the object would have to be less than a millimeter thick. Such a structure would be nearly impossible to form in nature, but it could theoretically be produced. Most of the scientific community was skeptical of Loeb's spacecraft hypothesis. Alternative theories were proposed. Hydrogen ice theory. It was suggested that the object was made of pure hydrogen, and the evaporating hydrogen was invisible to telescopes. Sponge theory. It was said that the object had a porous structure and was very light, so it moved with light pressure. Fragmentation theory. It was claimed that the object was the remnant of a planet torn apart by a star's gravitational pull. However, each theory had a weak point. Hydrogen ice was extremely rare in the universe, and a spongy structure would have disintegrated long ago during millions of years of interstellar travel. In 2019, a second interstellar visitor was discovered, Borisov. However, Borisov was completely ordinary. It was a typical comet with a distinct tail and gas outflow. This made Oumuamua even more mysterious. Why was one so normal while the other was so abnormal? New generation telescopes like the Vera-Rubin Observatory, which will begin operating at full capacity in 2024, may detect dozens of similar objects every year. Then we will understand whether Oumuamua is an exception or the rule. What Oumuamua was will probably never be known for certain. It is now too far away, no telescope can see it, and no spacecraft can catch up to it. All we have left are those few weeks of mysterious data from 2017. Perhaps Oumuamua was useless technology left behind in space by a civilization that vanished millions of years ago, much like our Voyager probes. This story reminds us that the universe is far stranger and more full of surprises than we ever imagined. When the next messenger arrives, we may finally get the answers to the questions we were afraid to ask. Today on Future Theory X, we explored the scientific debates surrounding Oumuamua, the first and strangest visitor from interstellar space, and the possibility that it could be a space sail. What do you think? Was Oumuamua just a cosmic freak of nature or a relic from an alien civilization? We look forward to your predictions in the comments. If this journey excited you, don't forget to like the video and subscribe to our channel so you don't miss this great cosmic discovery journey. Turn on notifications, because our next topic could be much darker and more mysterious. See you in our next video on Future Theory X.